This is a rough draft outlining the status flags for the Z80 microprocessor. The original documentation where this information originates appears to have some errors. Until I know more about this architecture, I have decided to go ahead and learn from the Zilog documentation despite this. If I discover that modifications need to be made to this document, then I shall make it known with an update. Remember, YouTube offers a speed adjustment setting if this text-to-speech is too slow or fast for your tastes. Signed, Electronoob. Z80 status indicator flags. The flag registers, F and F quote, supply information to the user about the status of the Z80 at any given time. The bit positions for each flag is listed below. Each of the two flag registers contains 6 bits of status information that are set or cleared by CPU operations. Bits 3 and 5 are not used. 4 of these bits are labeled as C, PV, Z, and S, which may be tested for use with conditional jump, call, or return instructions. Flags H and N are used for BCD arithmetic, therefore these two flags may not be used for tests. The table of bits for the flag register are as follows. Bit 7 is S. Bit 6 is Z. Bit 5 is X. Bit 4 is N. Bit 3 is X. Bit 2 is P or V. Bit 1 is N. Bit 0 is C. C is the carry flag. N is the add or subtract flag. PV is the parity or overflow flag. H is the half carry flag. Z is the zero flag. S is the sign flag. And X is not used. For the sake of improving retention, the flags are as follows. Bit 7 is for the sign flag. S. Bit 6 is for the zero flag. Z. Bit 5 is not used. X. Bit 4 is for the add of subtract flag. N. Bit 3 is also not used. X. Bit 2 is for parity or overflow flag. PV. Bit 1 is for the add of subtract flag. N. Bit 0 is for the carry flag. C. Carry flag. The carry flag, C, is set or cleared depending on the operation performed. For add instructions that generate a carry, and sub instructions that generate a borrow, the carry flag sets. The carry flag is reset by an add instruction that does not generate a carry, and by a sub instruction that does not generate a borrow. This saved carry facilitates software routines for extended precision arithmetic. Also, the DAA instruction sets the carry flag if the conditions for making the decimal adjustment are met. For instructions RLA, RRA, RLS, and RRS, the carry bit is used as a link between the least significant byte, LSB, and most significant byte, MSB, for any register or memory location. During instructions RLCA, RLC, and SLA, the carry contains the last value shifted out of bit 7 of any register or memory location. During instructions RRCA, RRC, SRA, and SRL, the carry contains the last value shifted out of bit 0 of any register or memory location. For the logical instructions AND, OR, and XOR, the carry is reset. The carry flag can also be set by the set carry flag, SCF, and complemented by the complement carry flag, CCF, instructions. Add or subtract flag. The decimal adjust accumulator instruction, DAA, uses this flag to distinguish between add and subtract instructions. For all add instructions, N sets to 0. For all subtract instructions, N sets to 1. Parity or overflow flag. This flag is set to a specific state depending on the operation performed. For arithmetic operations, This flag indicates an overflow condition when the result in the accumulator is greater than the maximum possible number, or is less than the minimum possible number. Plus 127 or minus 128 respectively. For addition, operands with different signs never cause overflow. When add-in operands with like signs and the result has a different sign, the overflow flag is set. For subtraction, overflow can occur for operands of unlike signs. Operands of like signs never cause overflow. Another method for identifying an overflow is to observe the carry to and out of the sign bit. If there is a carry in and no carry out, or if there is no carry in and a carry out, then overflow has occurred. This flag is also used with logical operations and rotate instructions to indicate the resulting parity is even. The number of 1 bits in a byte are counted. If the total is odd, odd parity is flagged. If the total is even, even parity is flagged. During search and block transfer instructions, the PV flag monitors the state of the byte count register. When decrementing, if the byte counter decrements to 0, the flag is cleared to 0, otherwise the flag is set to 1. During LD, a comma, I, or LD, a comma, R instructions, the PV flag is set with the value of the interrupt enable flip-flop, IFF2, for storage or testing. When inputting a byte from an I/O device with an IN, R, C instruction, the PV flag is adjusted to indicate the data parity. Half carry flag. The half carry flag, H, is set to 1, or cleared to 0, depending on the carry and borrow status between bits 3 and 4 of an 8-bit arithmetic operation. This flag is used by the decimal adjust accumulator instruction, DAA, to correct the result of a packed BCD add or subtract operation. The H flag is set to 1, or cleared to 0, according to the following rules. The rules for add-in are: if a carry occurs from bit 3 to bit 4, the half carry flag is going to be 1. If no carry occurs from bit 3 to bit 4, the half carry flag is going to be 0. The rules for subtraction are: if a borrow from bit 4 occurs, the half carry flag is set to 1, and similarly if no borrowing from bit 4 takes place, then the half carry flag is 0. Zero flag. The zero flag, Z, is set 1, or cleared 0, if the result generated by the execution of certain instructions is 0. For 8-bit arithmetic and logical operations, if the resulting byte in the accumulator is 0, then the Z flag is set to a 1. If the byte is not 0, then the Z flag is reset to a 0. For compare instructions, the HL register points to a memory location. The contents of that memory is compared against the accumulator. If the contents of memory and the accumulator are equal, then the Z flag is set to 1. When testing a bit in a register or memory location, the Z flag contains the complemented state of the indicated bit. When inputting or outputting a byte between a memory location and an I/O device, if the result of decrementing the B register is 0, then the Z flag is set to 1, otherwise the Z flag is 0. Also for byte inputs from I/O devices using the IN, R, C instruction, the Z flag is set to indicate a 0 byte input.